So the warm-up for today is just considering what we've already done. So if we remember back that terms that we know are broken up by addition and subtraction. So here we have 1, 2, 3 terms. So the name of this, if we're talking about the number of terms, is a trinomial. Which term has the highest degree? So when we're looking at degree, we're always looking at the exponents that are added on. So the term that are added together, so this one would have, the first one would have 2 plus 1, so that's 3. The second one would have 1 plus 1, and the last one would have 0. Okay, so this has, the term is 2x squared y. It's the third degree. Now if we substitute it in these values, I'm just going to erase this stuff so we can see it a little better up here. If we substitute it in these values, we're going to get something like this. So 2 times negative 1 squared times 2 plus 3 times negative 1 times 2 plus 1. That's going to equal, well, we can do BEDMAS. We're going to do exponents first. So negative 1 squared is positive 1. 2 times 1 times 2 is 4. 3 times negative 1 is negative 3, times 2 is negative 6, so minus 6 plus 1. So here we're going to have 4 minus 6 is negative 2, plus 1 is negative 1. Okay? So when we're collecting like terms, a like term is a term that has identical variables, meaning that they're the same letters and the same exponent. Okay, so the numbers in front don't actually matter. So here, those are like terms, the very first one, because we have x and the exponent is 1. The second one is x squared. The 7 and the negative don't actually make any difference, or sorry, a squared. So those are like terms. The next one is negative 2x squared and 5x. Those are not like because the exponents aren't the same. Negative 3 and 4a are not like because there's not an a with the negative 3. 3x squared and 3xy and 4xy are like terms. And then finally the last one, they are like, if you've noticed, all that's happened are the variables have just switched spots. They're still the same variable, it's n cubed and m squared. They're just in a different order. Typically, we would organize them alphabetically, but sometimes you organize them in decreasing degree. So looking at this, we've got our variables here are the same and the exponents are the same. So simplify by collecting like terms. Well, collecting like terms is like putting all of your apples together and counting them, or putting all of your oranges together and counting them. So here, we have 2x's plus 5x's is going to give us 7x's. The next one, we have 8a's minus 3a's is going to give us 5a's. And finally, the last one, we have 4f's added together. 1, 2, 3, 4. So this is going to be 4f. Because if there's ever not something written in front, we assume that it's a 1. Okay, moving on. The next one, these ones are a little bit harder. Now I'm going to do most of these in 2 steps. What I'm going to do is get rid of any brackets first, and then I'm going to add everything together. Okay, so this is going to equal negative b plus 3b, and then 2 negatives make a positive, and negative times a negative is a positive. So this is going to be plus 5b. So negative b plus 3, so negative 1 plus 3 is 2. Plus 5 more is 7. So that's 7b. Now this one, what we're going to have to do is we're going to have to put all of our h's together. And then we're going to put our constants together. Okay, so our h's, we have 2h plus 3h. So 2h plus 3h is 5h. And if you've noticed, I put a little box around those. And then I put a line under the constants. So 3 plus 7 is going to give me 10. And I can't do anything else because there's no more like terms. Okay, now on the last one here, I'm going to zoom in a little bit. This last one, we're going to do it like this. We're going to have y squared minus 3y squared plus 2. A positive and a negative gives me a negative. So minus 4y squared. So that means that I'm going to use this plus 1 minus 3 and minus 4 and put those all together. So 1 minus 3 is negative 2. Minus 4 more is negative 6 y squared. And then I just write that plus 2. That 2 can't go together because it doesn't have any y's attached to it. So we leave it out there. So that's collected like terms there. Okay, a little bit harder again. Here we've got negative 3w. Again, 2 negatives makes a positive, plus 3w. Well, negative 3 plus 3 just becomes 0. We don't even have to put the w. 0 is 0 no matter what. Okay, here, this one's a little bit harder. So first, let's get rid of all of our brackets. Now, you don't have to do this line, but I find when we're starting out, a lot of people make mistakes. 2 negatives is a positive. If they don't do this, they mess up the signs. A positive and a negative is a negative. They do something else that they normally wouldn't do. So here, we're going to have negative 3x squared is going to go with negative 5x squared. That's going to be negative 3 minus 5 more is negative 8. We're going to put our x squareds first, then our x's, then our constants. If we had cubed, we'd put those first. We always go from the highest degree to the lowest degree. So next, we're going to look at 2x minus 3x. Well, 2 minus 3 is negative 1x. And then finally, our 1 minus 4. 1 minus 4 is negative 3. Okay, and that's as far as I can go. You just collect until you're done. You can't put x's with x squareds or x squareds with constants. All right, now looking at this last one is actually already simplified. I'm just going to write it out to prove a point. There's only one EF, there's only one E term, and there's only one F term. So we can't do anything. That's as simple as it gets. All right, last ones. So it says simplify. So I'm only doing this just to show you a point. X cubed plus x cubed is 1 plus 1. So that's 2x cubed. But x cubed times x cubed, well, that's what we just looked at with our exponent laws. That's going to be x to the 6 because we add our exponents. There's one more I guess we could look at, would be something like this. So if we were looking at 3 and we had x cubed cubed, well, that one is going to be x to the 9. Okay, and that's really all you can do. All right, the questions for this are on page 151, number 1 to 9 and 11.